Hello students, welcome to CATCH25 Academy. Let us now continue with our questions. So we are now going to illustration 25. So in illustration 25, we are given two blocks. This is block 1 and this is block 2. And we have ground at the bottom. This is, let us say, ground. So the block on the top has mass m1 and on the bottom has mass m2. The force acting on block m2 is F2 and the force acting on block m1 is F1. So this is the diagram which we are given. Now in this case we have to find the static friction between the two blocks m1 and m2. So let us see how to solve this question. So let us first make the diagram. This is block M1, this is block M2, and this is ground. Now, on M1, I have a force F1 towards the right. On M2, I have a force F2 towards the right. If I draw the free body diagram individually, so in this case, we have M1 block. So rightward force F1, M1G in downward direction, normal reaction N1 by block M2 on M1 in upward direction. Now, because of this force, let us say M1 moves in forward direction with some acceleration, let us say A1. So kinetic friction in this case, if at all there is. So in this case, we have to find static friction. So static friction will be so as to keep the block at rest. The static friction will be in backward direction, let us say F. And by action reaction pair on block M2, static friction will be in forward direction. F2 force will also be in forward direction. Acceleration A2 of block will also be in forward direction. But if this is static friction, then we can say acceleration A1 will be equal to A2. Because if we have static friction, then there is no relative motion. Other than that, in vertical force, we have M2G and normal reaction N2 by ground in upward direction and N1 normal reaction by M1 on M2 in downward direction. So in horizontal direction, we can say force balance on M1 gives F1 minus small f, big force minus small force. Because F1 is in the direction of acceleration, it is big force minus small f is small force. So this equals M1 into A1. For M2 block, we have F2 plus small f, friction force. That equals M2 into A2. So these are the two equations. Now we can say acceleration A1 will be equal to A2 for static friction to act. Because if we want static friction, the acceleration should be same. There should be no relative motion. So A1, which is F1 minus small f upon M1, this is equal to F2 plus small f upon M2. So if I solve these two equations, friction will come out to be M2F1 minus M1F2 upon M1 plus M2. So this is the value of static friction which we need to find. So this is how we solve this question. The value of static friction is as shown in this box. So after this, let us move on to next question. Next question is illustration 26. So we are given a diagram as shown. Now we have two blocks. One is this block and another is this block. So suppose this angle is theta, this is block M2 and this is M1. So in this case, if there is no relative sliding, that means only static friction will act. So we have to find the value of static friction. So let us see how to solve this question. So in this case, let us say there is no relative motion. That means both the blocks M1 and M2, they move with same acceleration in down the inclined direction. And we have to find the value of friction between the two blocks. Now, if I consider in this case, no friction, if we assume no friction, if we want them to move together, so this will have acceleration M1 g sine theta, this will have acceleration M2 g sine theta. So both will have same acceleration. So this is the force on these two blocks, M1 g sine theta, M2 g sine theta. And this is equal to mass of M1 into acceleration of A1. This is mass of M2 into acceleration of A2. M2, M2 cancels, M1, M1 cancels. So A1 comes out to be g sine theta. A2 also comes out to be g sine theta. So value of relative acceleration A1 minus A2, it will come out to be 0 because it is g sine theta minus g sine theta. So g sine theta minus g sine theta is nothing but 0. So we can say in this case, no friction acts. So friction is 0 in this case. So there is no tendency of relative sliding. Friction here is 0. Going to next question. So in question 27, we have two blocks, small m and capital M. On capital M, we have a force capital F. Now, in this case, there is no friction between ground and M. So here we can say friction is 0. Between small m and capital M, we have mu s and mu k. These are the values of coefficient of static and kinetic friction. So we have to find the maximum value of capital F so that they both move together. Both blocks move together. That means static friction acts. This is the first question in this question. Second question, we have to find the acceleration of blocks if capital F is greater than part A of the question. So we'll first solve part A. So let us assume both blocks move together. So in that case, both if move together, that means they have same acceleration. So acceleration of this block small a, acceleration of this block also small a. So acceleration will be total force on the system, which is capital F, upon total mass, which is capital M plus small m. Now, small m mass, it will have friction force in forward direction and acceleration A in forward direction. So friction is mass into acceleration. Mass is m, acceleration is capital F upon small m plus capital M. So the value of friction comes out to be mf upon m plus capital M. So this is the value of friction. Static friction comes out to be this value. Now, static friction, it lies between 0 and mu s m. So in that case, we can say this is the value of static friction, mf upon m plus m. In second part, we have so it is we have acceleration. We have to find the value of acceleration. So to find the value of acceleration in second part, let us see how to solve this question. So let us consider capital F friction. So if this applied force is greater than force in capital F, so in that case we have capital F, which is the applied force, minus small f is equal to capital M into acceleration A. So this is the equation for this capital M block. So capital F comes out to be friction plus capital M into A. And the value of friction we already found. We can substitute this value of friction here. So from this, we can calculate the value of capital F. Now A also we can substitute from this equation, we'll get the value of capital F as required. So first let us get the value of capital F. So capital F is equal to small f plus capital M into A. So small f is nothing but mf upon m plus n. It comes out to be capital F itself. Now in second part, we have to find the acceleration of the blocks if f is greater than the value found in first part. So we can say in that case, friction force mu s into mg. This is the maximum value. This is less than small f into capital F upon capital M plus small m. Why? Because this is the value of friction which we found. It has to be less than mu s into mg. So from this capital F value, we can say it is less than mu s into capital M plus small m into g. So this is the value of capital F. Now, if in second part of the question, if this force is greater than mu s into capital M plus small m into g, then we can say there is sliding, there is kinetic friction, there is sliding, there is relative motion. Between small m and capital M. So we can say kinetic friction Fk is mu k into n. And we can say kinetic value friction will be mu m into A1 because force is mass into acceleration. So from this A1 we can find out. So A1 will be coming out to be mu k into n upon capital M small m. So this is mu k into mg upon m, which is mu k into g. So acceleration A1 comes out to be mu k into g. For second block, capital M mass, we have acceleration given by this equation. We have the forces on second block, capital F. Kinetic friction will be in backward direction. So capital F minus small f, kinetic friction is equal to capital M, mass of second block into A2. So A2 will come out to be capital F minus Fk upon capital M. So the value of acceleration A2, it will be capital F minus mu k into g mg upon capital M. So this is the value of acceleration of second block. So these are the answers to this question. Acceleration of first block mu k into g, acceleration of second block capital F minus mu k mg upon capital M. Now after this, let us move on to next question, which is question 28 of illustration questions. So in next question, we again have two blocks and ground. So this is small m, this is capital M, and this is force capital F. Here in this case, there is no friction between ground and capital M. So mu is 0 here, and here we have mu s and mu k again. Now, in this case, we have to find the maximum value of capital F on the upper block in this case, so that both move together. So first, if I consider both of them as system, so acceleration will be total force on the system, which is capital F upon m plus small m. So this is the acceleration of the system. Now let us consider the forces on individual blocks. So the first body diagram of small m. So capital F force, acceleration is A, mg acts in downward direction, normal reaction is n1, and friction will be in backward direction. On capital M, we will have friction in forward direction, and we will have capital Mg, normal reaction n2 by ground on this block, and n1 in downward direction. So these are the free body diagrams of the two blocks. Let me show the divider between these two diagrams. Finally, we also have the acceleration of second block. It is a same acceleration. So small f, if I consider on lower block, if I draw the diagram of this block, it will be capital M into A. So capital M into capital F upon M plus N. So this will be the value of friction. Now, in this case, we have to find the value of acceleration. So if I consider in this case, capital F value, we have to find out. So capital F value we can find out in this case. It will be friction force maximum value, which is nothing but maximum value of friction force will be mu s mg. So this is maximum value. So we can say we will have this value will be greater than this because this is maximum value. Like this. So capital F we can say is less than or equal to mu s into m plus m into g upon capital M. So this is the value of applied force. Now, once you understand this concept, let us consider the acceleration A1 and A2 of each block. So if we consider this as A1 and A2, so we can find the value of A1. How? By force balance. Like this. So from this we'll get A1 and this is MA2. So from this we'll get A2 value as well. So we can find A1 and A2 if required. So this is how we solve this question. So after this, moving on to next question, which is illustration 29. In illustration 29, we are given three cases. So let us do first case. We have a block, two block system again, and we have ground, and we have a wall here, something like this. So there is a force capital F on this lower block B. So suppose this block has weight 4 Newton, this block has weight 8 Newton. The coefficient of friction between all surfaces is 0.25. So in this case, we have to find the force capital F to make B slide constant velocity. That means acceleration is 0. So let us see how to solve this question. So acceleration is 0. We want in this case acceleration is 0. So both the blocks move together in that case. So we can say friction is static. There is no relative motion. So that means we can say acceleration is 0. We have to find the force for B to slide at constant speed. So that means we will have applied force is equal to kinetic friction, because applied force here and kinetic friction in backward direction. So applied force is equal to mu k into n. So mu k in this case, it acts in backward direction. Normal reaction here acts, which is m plus m into g on the lower block. Why? Because on A block we have small mg, n1 force, and on block B, and friction is in forward direction. That is something like F1. Here we have friction F2, F1 in rightward direction on capital M, and we also have friction which is Fk in forward direction between ground and block, and this is capital F. And we have normal reaction N2 and capital Mg and N1 value. So from this N1 is Mg. So let us substitute N1 is Mg. So by vertical force balance on this capital M, we have N1 plus Mg is equal to N2. So N2 will come out to be small m plus capital M into G. So this is the value of N2 which we have substituted here. So in first case, we can say applied force is mu into m plus m into G. This is the answer to first case. Now, in second case, we are tying this by a string. A block is tied with a string to the wall here. This is the wall. So A will be held at rest. So A will be held at rest in that case. Now, if A is at rest, so in that case, what will be the direction? We will have tension force on A in forward direction, which is T. The rest all will remain same. where there will be tension force, that's it. So in that case, we can say friction F2 on the lower block, this F2 friction, this F2, let us say this is F2. So this F2, it will come out to be mu N2, which is nothing but mu into M plus M into G. So this is the value of friction force again on the lower block, between ground and lower block. So that is how we solve the friction. And F1 friction here will be, so F1 will be mu N1. So N1 value is nothing but mu into M small m into G. So this is the value of F1. So that is how we solve the value of friction. Now, if I want to find the value of capital F force, horizontal force balance, that is nothing but F1 plus F2, which we just found. F1 value, F2 value. If we add these two, we'll get the value of capital F force on the block. Finally, if I take the next case, so in next case, we have the same system in this question. And we have the ground at the bottom. But we have a pulley in this case. So we have a pulley like this. So one end of the string, let us say, which I show in golden color, is here. Another end is here, like this. Now, after this, we have a block which is like this. And this is connected to the wall. Now this is block A, this is block B, and we have applied force, capital F. So in this case, we have to find the force F so that the block B slides with uniform velocity. So let us think about the free body diagram of each block. Block A, this is block B. So one force, we have tension on both the blocks because now both the blocks are connected to string. Then we have friction F1 between A and B, and reaction pair, this will be F1 here. And we have capital F force, which is in this direction. The friction will be in backward direction, F2, between ground and this block B. Then we have capital Mg downward direction. This is small mg downward direction. Normal reaction N2 upward direction. Normal reaction N1 upward direction. And normal reaction by small m on capital M in downward direction. So these are the forces. So horizontal force balance here gives P is equal to F1 is equal to mu N1. So P comes out to be mu MA into G. So this is the value of tension force. Now for block B, we have capital F is equal to F1 plus F2 plus capital T. So this is the force balance. So let us consider the values. Capital F will be F1. What is the value of F1? It is mu into MA into G plus F2. F2 value will be mu into 3. We will have what? What is the value of M which is given to us? So in that case, we have mu into, this is the value. Capital F force is this. So here we have 4 Newton. Here we have 8 Newton. So MA into G, we will consider 4 Newton. And in this case, for F2 friction, we will have MA plus MB. So 8 plus 4, which is nothing but 12. So here we will have 12. 12G. It's 12 Newton, sorry, this is 12 Newton. 12 Newton force in plus tension force T. So tension force T we have already found, which is mu MAG, which is mu into 4. So that is how we'll find the value. Capital F will come out to be mu 4 plus mu 12 plus mu 4. So calculating, we get the value of F as 20 mu. So this is the value of capital F force. So that is how we solve this question. In the next question, which is question 30. So in illustration 30, we have a diagram which is given to us. We have a string also. This is the string. And the string is connected to few pulleys. So this is pulley number 1 here. This is pulley number 2. And we have a man here. And this is pulley number 3. So this is the system which we are given. Now, man has mass capital M, this block has mass small m, and there is a wall which is given to us. So this is the wall. These are the connection by the wall to the pulley. So this is the diagram. Now, in this case, let us think about the forces individually. So tension force in upward direction, tension force in this direction. Then we have mass into gravity, mg force in downward direction. Normal reaction, it will act as well. So mg of the man. So if I consider the man, what are the forces on the man? On the man, we have its weight, tension in upward direction. Then we have friction. So in this case, what is the friction coefficient between board and floor? So friction on man will be in backward direction. Is there a friction between man and board? The friction coefficient man and board between the board and floor is given to us. So we don't have friction between man and the board. So after this, let us draw the diagram of the board. So for the board, we have, this is the board. One force is mg in downward direction. We have another force which is normal reaction in upward direction. Friction force acts in backward direction. Tension force acts in forward direction. So these are the forces on the board. These are the forces on the man. On the pulley, we have forces like this, T and T. On another pulley, we have forces like this, T and T. On another pulley, we have forces like this, T and T. This is how we have forces here. Now, let us say normal reaction by the ground on the board is N2. Normal reaction by the board on man is N1. So there will be N1 force here. This is force of man on the board. So these are the forces which we have. And once we have marked these forces, we want to find the maximum value of capital F that man can exert. So that means we have to find the value of tension because man is exerting force on string. So we have to find the value of tension. So we have to find the maximum value of tension. So in this case, if I draw the diagram, so we can say along vertical direction, we have N1 plus T is equal to mg for the man diagram. Now, if I consider the man and board as a system, if I consider the man and board as a system, so this is man and this is board here. So what is the total force acting M plus M into G on the system, man and board system? Normal reaction is N1 and we have a tension force T. So N1 plus T, that equals M plus M into G. So this is the value. N1 plus T is M plus M into G. Then in this case, we want, the question says there should be no sliding on floor. So we can say no sliding means there is no relative motion. So this maximum value of friction will act. So maximum value of friction will have mu n. So maximum value of friction is mu n in that case. So this is mu into M plus M into G minus T. Why? Because N1 from here comes out to be M plus M into G minus T. So from here we get the value of N1 as M plus M into G minus T. So after this we have F and T, they are equal. So we will be able to find F from this equation, which is nothing but tension force. So From this, I can find the value of tension force T, which will be my answer. That is how we find the value of tension force, which is nothing but the applied force. Let us move on to question 31. So this is capital M, this is small m. In this case, coefficient of friction between two blocks is given as mu. We have to find the minimum value of horizontal force to hold the two blocks together. So in this case, let us consider ground as frictionless. So friction between ground and capital M is 0. Let us draw the free body diagrams of each block. So for capital M, one force is mg. But this one also we have a force. Here we have normal reaction like this, normal reaction like this. This is capital M, this is small m. So there is normal reaction here, N2, let us say. So here there will be normal reaction, N2 on this block. This is the divider. So capital M is applying up N2 force on small m. N2 is also applied by small m on capital M, action reaction pair. Capital F is applied force, N1 is normal reaction by ground on capital M, Mg reacts in downward direction. So friction in this case, what will be the direction? So friction from small m will act in upward direction. Because to avoid this from falling, friction has to act in upward direction. So on this, friction will act in downward direction. This is the direction of friction. Now this friction is equal to mg in vertical direction. So this friction will also come out to be mg. We have to find the minimum value of capital F. Capital F minimum value we have to find, so that the two blocks are held together. So we can say small f is mg. Now friction is mu n, but the value of friction maximum value mu mg. In this case, it will be mu ma. Why? Because both the blocks are accelerating in right direction with a acceleration. So n2 is ma. So friction value F is mg. So maximum value of friction will be mu m. Mu m. This equals mg. So we can find the value of acceleration. It will be g by mu. Now, if I apply a capital F force balance, we have capital F minus N2 is equal to capital M into A, acceleration. The acceleration A is nothing but g by mu. So from this, if I substitute the value of capital N2, N2 is nothing but in this case, N2 value will be MA, small m into A. So capital F minus small m into A is equal to mu g by A. Is equal to, we have capital M into this. We have the value here. This is capital M. So A we can substitute as g by mu. So mg by mu. So our answer will come out to be capital F is equal to m plus m into g by mu. If I take g by mu common, So this is our final answer. The final answer to this question, applied force is m plus m into g by mu. From this equation, so this from this equation we'll get our answer. From this equation. So this is how we solve question number 31. So I think now you can manage the question 32, 33, 34. A few questions now are of the same type as we have been discussing. So you can manage these questions. So let us now move on directly to question 35. So let us see question 35. So in question 35, we have a wedge like this and another wedge on this. There are two wedges, and on top wedge we have a baby. So this is wedge B. Let us say wedge A. This angle is given as 60 degrees. Now, in this case, we have to find the minimum coefficient of friction between baby and triangular block B. We have to find the coefficient of friction, mu, so that the baby remains stationary with respect to block B. So baby is stationary with respect to block B. Let us draw the free body diagram individually. So for the wedge and the baby, let us think about the forces. On the baby, we have normal reaction N, and in this case, we have acceleration down the incline. So this will also be the acceleration A naught of the baby. So pseudo force M A naught acts in opposite direction. Pseudo force acts opposite to acceleration. Acceleration is A naught down the incline, so M A naught pseudo force acts up the incline on the baby. So we have, other than this, there is a friction force on the baby. So friction will be taking baby in horizontal direction towards this direction, and mg force will also act on the baby in downward direction. So if I take the component of this will be 60. So this will be m a naught cos of 60, and this will be m a naught sine of 60. So friction comes out to be m a naught cos of 60. Other than this, we have other equation which is for the incline. So for the incline of B, we have various forces. So one will be normal reaction, NBG, and acceleration is A. So these are the forces acting on this block. Okay. So we have, in that case, what is the value? If I do force balance in vertical direction for the baby, we have N plus M A naught sine of 60. That equals mg. So these are the force balance equations in horizontal and vertical direction for the baby. So now we can solve these equations, and we can get the value of mu. So that is how we'll find the value of mu. First we'll write friction value. So friction maximum value is mu s into n, and we will substitute this value of n. So from that we can find the value of mu. So let us see how to do that. So friction is mu s into n. N value will substitute from here. So m a naught cos 60 is equal to mu s into n, which is mg minus m a naught sine 60. So m cancels on both sides, and we have to find the value of mu s. So mu s will be a naught cos 60 upon g minus a naught sine 60. Now acceleration a naught is g sine theta. So g sine 60 cos 60 upon g minus a naught, which is g sine 60 into sine 60. So we have to solve this equation, and on solving this equation, we'll get the value of mu s. So that will come out to be root 3 because g will cancel. So we'll get mu s is sine 60 into cos 60, which is nothing but root 3 by 2 into cos 60 is 1 by 2, divided by 2 into 1 minus sine 60 into sine 60. So 3 by 4. So that will come out to be root 3 by 4 upon 1 by 4. So this cancels, mu s comes out to be root 3. So that is how we solve this question from the free body diagram of the baby. So that is how we solve question number 35. So this is how we solve various questions based on friction. We have taken various different type of examples wherein we have problems based on single block. We have to find friction. Then we have multiple blocks which are kept horizontal and we have to find friction. Then we have multiple blocks or single block placed on an inclined plane. So we have multiple blocks placed on an inclined plane along with a pulley. Then we have solved questions which are based on pulley and man, which are man is placed on a board, and we have solved questions based on two wedges. So this is how we have questions based on friction force. Do practice more and more questions based on this topic, and we will continue with circular motion in our next session.